we've done one step, which means we're going to kind of cruise through this. So I am literally going to show you one example of how to do your two-step inequality, keeping in mind the fact that if there is multiplication and division involved, the potential of having to switch that inequality sign around is going to be there, okay? So if I said negative 3x plus 7 is less than or equal to 8, simple, right? You know that step 1 is going to be always to cancel the constant, so you will subtract your 7 from both sides. You're going to get negative 3x. I didn't flip anything around. Let's use, so I'm not switching anything right now. 8 plus negative 7 is 1. Now I'm about to go and divide by a negative 3. And because I just divided by a negative, this is no longer going to be a less than sign. It's going to be a greater than or equal to sign. And how can I clean my answer up? You don't really need to do anything to it. Your answer is just 1/3, negative 1/3. Okay? And because part of the graph is going to ask you to answer that, if this is negative 1, the graph may already be identified like that for you. You just have to know to put a closed circle at negative 1/3 and shade to the right, okay? That's all I'm doing for two-step because we should be past that. So let's move right into multi-step inequalities. And we're going to kill two birds with one stone here and kick out some decimal problems, okay? Remember, don't always assume that you need to run and grab a calculator for these decimal problems. It's actually not that bad. So by the time it actually took you to run across the room and get your calculator out or take your phone out, this is just negative 1.6x. Negative times negative is positive, so I'm going to put a plus sign here. If I know what 6 times 5 is, then I know what 0.6 times 5 is. It's just moving that decimal over once. So if 6 times 5 is 30, 6/10 times 5 is just 3. So that's going to be plus 3, less than or equal to 15. So you know that your multi-step involves some distributing, right? Subtract 3, and you should, we're going to have a little bit of a division problem with a decimal, but that's okay. We'll walk through that one too. I am going really fast because this is a little bit of a review. So, did I just multiply or divide by a negative? Yes. So that less than symbol is now a greater than, and you don't need a calculator for this either, because if you know 12 divided by 6, if you can't divide by a decimal, you have to move it over, right? So that becomes 6, and I have to move it over here. So your answer is actually 120 divided by 6, which is negative 20. Okay? So there's your token decimal problem. So if this is 0, 20 is here. Actually, we're doing negative 20, which is going to make 0 over here. That's going to be negative 19. This is going to be negative 21. It can also be this, and we are going greater than that. So for the first 10 problems on the packet of practice, you still have to graph them. And then finally they say, oh my gosh, you've graphed enough. You can just solve them and be done. Okay? So that's multi-step. Let's do a multi-step with a fraction. We did a decimal. Let's do it with a fraction. So let's take negative 1/4 times p minus 12 and have that be greater than negative 2. Remember what I said about when you have a fraction and you're about to distribute it? Sometimes it's actually okay to distribute it. Other times you just want to get rid of it. So if you distribute this, you're going to have a negative 1/4 p and blah, blah, blah. So do you want to just get rid of it? Let's try it that way. What is the reciprocal of a negative 1/4? Negative 4 over 1. So I'm going to multiply both sides by a negative 4, right? Which then, I cancel the 4s, I cancel the 1s, I cancel the negatives. Everything's great. This is exactly why I did that, because I want nothing left but that. And now that is just greater than or equal to 8. And now I, sorry. This is exactly why I did this problem. I'm doing too much at the same time. Anybody catch me? Yeah, what did I do? This is exactly why I did this. I multiplied by a negative. So that can't be a greater than sign. It's got to be what? Less than. So it has to become habit for you. That's 8. Now I'm adding 12. And my answer is going to be P is less than 20, which means then you have your open circle and you go to the left and 0 is here, okay? Easy enough? So that was your distributing, that was your fraction, that was your decimal. Now let's do variable on both sides. 6x minus 7 is greater than or equal to 2x plus 17. I really love teaching this lesson because this is probably the lesson that I could have given you the practice sheet and said, hey, just do it. Combine everything I've already taught you from 3 different lessons, and I bet you could do these problems, right? So I'm literally doing one of each. So remember when we talked about variables on both sides? There's 4 ways to do this. I'm deciding that I like my variables on the left, and by the way, I like them on the left in equations. I really like the variables on the left when it's an inequality, right? So for all of you who are okay with like, oh, 8 is equal to x, you might change your tune when it's an inequality, right? Because you want it on the left so you can graph it correctly anyway. So I'm going to choose to subtract 2x from both sides. You may have chosen to subtract 17 from both sides, or add 7 to both sides, or subtract 6x. You remember, you could do it however you want. I like to take care of my variables first, get them on the side that I want them on. Nothing's going on with the sign. I'm not switching anything right now. Now I need to get this over here. We are separating, and now I have a little baby 2-step equation. And luckily my x is positive, so I don't need to turn it anyway. Don't go getting flip happy and start turning it just for the heck of it. And so now x is greater than or equal to 6, and you know the drill from there. Solid circle, shaded to the right. All right, let's talk about these things, special cases. So there are a few things that I know you know how to do everything I just showed you. I want to point something out here, though. So if you've followed me so far, this is going to be something a little bit new. If I have 14x plus 5, and that is less than 7 times 2x minus 3, if I were to just leave this, distribute that, okay? You know something's going on, kind of like when I went over your test with you. Remember how you know something weird's going to happen? This is going to either be no solution or all real numbers. There's no way I'm going to have an answer like this because the variables are going to disappear. Okay? At this point, you have enough information to give me an answer. Meaning, if you know these are going to cancel, you normally, if this was an equation and I had 5 equaling negative 21, I'd be able to stop and say, no solution. But that's not an equal sign. So because it's an inequality, just looking at 5 over here and negative 21 over here is not enough. I have to investigate a little bit further. So I have to see if 5 is in fact less than negative 21. Is it? No. In this case, the answer then is no solution because it's not less than it. But what if that sign was flipped around? Then would it be no solution? No. It would actually be all real numbers because 5 would be greater than negative 21. So when you have these special cases and your variables cancel, you have to investigate a little bit more. Don't just go, oh, those numbers aren't the same, no solution. Yeah, if it's an inequality or if it's an equation, but not if it's an inequality. Good? All right, so try this one then. 12x minus 1 is greater than 6 times 2x minus 1. So you can kind of anticipate. I'm just going to do the other example. So you have your 12x and your 12x. I mean, you know, if you want to see it through and you want to see those variables cancel, you can do that. You don't need to. You can just look at them, know they're going to cancel, and see what's left. So is negative 1 greater than negative 6? This time it is, which means it's a true statement. And what does that mean in terms of your solution? It means all real numbers, infinitely many, identity, whatever you want to call it. It means that every number on the face of this earth that you can think of that you put in for x, every time you put it here and here and do this math and do that math, this side will always be greater than this side. Do you understand that that's what all real numbers means? There's not a number that you can think of that wouldn't work. Okay? So that is special cases. Very good. Let's move on to the verbal part. So our verbal portion says this. You have to translate. So for more than the product of, sorry, a lot of writing, 8 and y is no more than -6. Okay, so let me give you a minute to get that written. But remember, this is where we're taking the verbal sentence, turning it into a problem with an inequality sign. We're solving that inequality, and then we're graphing it. Okay? So you got to be careful because this is a two-step one. It's no longer just going to be x plus 2. It's going to be a multi-step. For more than. This doesn't say greater than. It says more than. So what does more than mean? It means that something is there first and you're adding for to it. So put the more than in the second spot. Then I go back and I look to see what for is more than. Oh, it's more than the product of 8 and y, which I write 8y. You with me? Then I look at is no more than. If it can't be more than, it can be -6. It can't be more than it, which means it needs to be less than or equal to it. And there you have it. Okay? Does this look familiar? We've done these problems before, except instead of saying is no more than, it said is -6. And that's when we were working with equations. But now we are working with inequalities. So let's try a variable on both sides. The sum of 5x and 2x, and then you would solve that, by the way, is greater than the difference of, this is an interesting one, 9x and 4. The sum of 5x and 2x, all of that, is greater than the difference of 9x and 4. So basically, are you picturing this right now? You have a sum on the left-hand side. You have a difference on the right-hand side. And what's over here is greater than what's over here. So you guys are already writing it, I can tell. So this sum is greater than this difference. And then you would solve however you want. Now, here, I want to point something out real quick. Now, normally, I am a get the variables on the left kind of girl. If I do that, actually, let me ask you, would there be any reason why I want to change up my strategy right here, right now, maybe? If I do that, what type of variable am I going to have? A negative one. Because when I subtract 9x, I'm going to have a negative 4x over here. But if I know I'm not a pay attention to detail kind of person, and I might forget to flip the sign, then I have to choose from the other evil. What's the other evil? Bringing the x over here, and then the x will be on the right. So when you have this problem, you have a decision to make. Are you going to be able to graph it with the x on one side, or are you going to be able to remember to flip it? You have to pick one of them. Got it? Okay, very good. So those are our verbals. So now let's go to our area problems. So I want you to go ahead and in your notes write your area problems. We are almost done. Okay? So an area of a rectangle is length times width, remember? And be careful, because we're just coming off of perimeter problems, right? You know that perimeter problems has to do with all the distance around. But let's say I have a space in my yard and I want to make a garden, but I want that garden to be at least 81 square feet. Okay, this doesn't have to be a square, okay? We're going to go with the rectangle right now. So what do I want my area to be? How do I write at least 81 square feet? I want it to be greater than or equal to 81. This side length on my garden happens to be 9, and this is x plus 2. So for these area problems today, I'm not asking you to find the area. I'm going to be asking you to find x today. So guess what? I gave you all the information you need. You're probably already setting it up in your head, aren't you? Area is length times width, and this times that needs to be greater than that. Go, set it up. It's actually really simple. Length times the width needs to be greater than or equal to 81. And when you solve that, you obviously have 9x plus 18 is greater than or equal to 81. And then you're going to subtract 18. Be careful doing this. So 9x is greater than or equal to, take 20 away from 81, and that gives you what? 61. So add 2 to it, right? So that's going to give you what? 63, which is great because 9 goes evenly into it. I need to make sure that that length is greater than or equal to 7. And then I will have a garden that fits it. So remember, we are talking about the actual area of dirt, not the distance around it. That's perimeter. I may want to put a fence up later, but that's not this section. So don't find the perimeter for these problems, okay? Do you remember the area of a triangle formula? Some of you did not remember it for the test. So what's the formula for the area of a triangle? Yes, and I'm glad he said that way. My instinct is to just write half of the base times the height. You could also use the base times the height and then take that product and divide it by 2. That will work. Okay, I'll show it to you both ways. So let's say the height of my garden, and I have an odd space in my backyard. It's a triangular shape. And you guys know why where that half comes from, right? Because area is half of that. And this is the length, and this is the width. But I don't have a big space, so I have to make sure that the area of this garden is no more than 44 square feet. So what's another way to write my area? If it can't be more than 44 square feet, it can be 44 square feet, just can't be more than it. Okay? So now be careful when you set this one up, because you're taking half of the base times the height, or you're taking the base, actually, well, it doesn't matter. The base, which is technically x plus 1, times the height and dividing it by 2. I'm going to show you that you can get the same answer both ways. And that needs to be less than or equal to my desired area. So because multiplication is commutative, I can do any order that I want. I'm going to take half of 8 first. Half of 8 is 4. And now I've completely gotten rid of that fraction. I'm going to distribute this and get 4x plus 4. Lots of 4s. I'm just going to fly through this. You can go ahead and stay with me here. Okay. So I know that the x value here has to be less than or equal to 10. Let me show you how I get 10 over here also, just for the heck of it. This is coming eventually. So I'm going to distribute the 8x, or the 8 to the x. So you know what distributive property means with multiplication? When I see one number in front of a parenthesis, it means the x and the 1 both have to get multiplied by the 8. What's that? It means the 8x and the 8 both have to be divided by the 2. So it's like a distributive property, but division. So this means take the 8x and divide it by 2. Take the 8 and divide it by 2. You don't have to write it out like that. You could really just kind of, you know how I do arrows up here? You can do arrows here. Do that by 2, do that by 2. And what do you get? You get 4x plus 4, just like I did here. And then you finish solving it that way. Good with that? Whichever way you like, go for it. Okay? Done on that? So now in the next section is going to be application problems. Okay?